Hello and welcome, everyone. We're super excited to have you join us today. We'll be spending a little bit of time talking about function calling Gemini, which is around a native framework for connecting LLMs to external systems, data, and APIs. Super excited to be here today. I'm Julia Wiesinger. I'm a product manager in Google Cloud, and I also am joined by one of my favorite partners from our DevRel team, Chris.
Yes, hi everyone. Chris Overholt here. I work in Cloud DevRel, mainly focusing around ML AI and a lot of our generative AI functionality. So thanks, Julia. Very excited to talk about function calling with everyone today.
Awesome. So we just want to give you a little bit of a roadmap on where we're headed today. We'll start with giving a little bit of an overview of generative AI in Google Cloud for those of you that are new to Google Cloud or that haven't had as much context as to what we've been working on from a Google perspective with regards to AI. We'll then jump into some of the challenges that we see and how function calling in Gemini can actually support these different challenges. And then I'll hand the floor over to Chris, who will jump in to some use cases and demos, share a little bit about why our developers love function calling so far, and then we'll go into a summary, share some resources, as well as do a live Q&A. So we're excited also to take some of your questions. And with that, we'll jump straight in. So to give you a little bit of context with regards to Gen AI and Google Cloud, obviously, the generative AI world has transformed a lot of the way that we work, a lot of the way that we do things in the last year, and has been moving incredibly quickly. The advancement is happening rapidly. You see new things coming out on a daily basis, and it's really, really exciting to work in this space right now, and also to be thinking about all the things that we can bring to our users, to our customers, and to our developers, and to really make their lives easier and better as they start to integrate this technology into the systems that they're building and working on. And with that, it's also important, I think, to take a little bit of a step back and think about the history of all of this. Research and innovation around LLMs has kind of been the backbone of Google for a long time. We've been an AI first company from kind of 2017 onward, and has been the driving force in a lot of the advancements that we see today. If you think about transformers or our diffusion models that all provide the basis of the generative AI models and LLMs that we see in the industry today. We were speaking to some industry analysts recently, and they actually said Google is a bit like the founding fathers of the LLMs. And for us, the way we see it, this is really just the beginning. So as many of you know from our announcements at the end of last year and continued announcements through this year, we've been very focused on our newest series of models known as Gemini, both open sourcing some of those models in Gemma, as well as the Pro and Ultra versions that are available in our developer tooling, such as Vertex. And as you saw with the Gemini Pro 1.5 release, we will continue to innovate, adding the million context window, continuing to iterate on various capabilities from a function calling perspective that we'll talk about today, and bring new features to the market through the course of the next couple of months. And we're really excited to share some of those things with you today. Also, for those of you that aren't aware, we have our big conference coming up at Google Next from April 9th to the 11th, where we'll be sharing lots more updates around what has been going on with Gemini within Vertex as a whole. So really excited for any of you that are going to be joining us there. And with that, I just also wanted to touch a little bit on the unique positioning that Google has to bring to this space. It's really not just about the model at the end of the day. It's about the entire stack that you're choosing to work with. Yes, you want that world-class model that is brought by the research and innovation that we've been driving in the space, but you also want kind of a fully integrated stack across the board that brings together the infrastructure components, such as our TPUs, as well as the platform like Vertex, where we bring together both the predictive and generative side under one roof in an enterprise kind of compliant way for our customers. And that's really exciting for us. I think we really have a true vertically integrated stack across the board, and we're really excited to bring that to you and share that with our customers. And from there, we'll jump into the thing that's particularly interesting to the audience here today, which is a little bit more context to function calling, to Gemini within function calling. And to start off with, we'll look at the of these real world applications with generative AI. And I think this is particularly interesting because large language models actually do have some limitations. They're super exciting. Lots has been happening in the space. But as you started to play with them, as you started to kind of see their outputs, there are some challenges that make it difficult to actually integrate them into a broader application. And those things kind of are really threefold that can also then ultimately be addressed from a function calling perspective. First, we see a lot of inconsistent output. So even with really good prompts, LLMs tend to produce inconsistent outputs in some ways, making it hard to actually implement some of this from a downstream perspective. Furthermore, they're frozen in time. So they lack any access to information after their specific training date, which can lead to those stale and inaccurate responses like, I was trained up until a certain date, and as of that point in time, I don't have any information past that point. And they're also disconnected from the world in that sense. They have no inherent way of interacting with the world, limiting their ability to actually take action on behalf of the user through common interfaces that we see today, like APIs. And that's where we really see opportunity for function calling and for using function calling within applications like the ones we'll see from Chris a little bit later in the session. It provides the ability for us to create consistent outputs. So by having a structure, we can use downstream to implement different chat implementations and actually ultimately ensure that we get consistent outputs for our users and for our customers. Outside sources, so recent news, events, etc. And finally, at the end of the day, the goal eventually is to be able to complete transactions and think through what those different flows would look like. So looking at buying different units of a SKU in this case, or other opportunities from that perspective. And while these are kind of the single point components, they then turn into kind of full-fledged applications that can take various different forms across the board that we've started to see. So many of our customers are implementing things like employee assistance to make their internal teams more productive, thinking about customer experiences and how they can integrate that into their customer experiences to make those smoother, more interesting, more dynamic, rather than the stale phone trees that we've classically known. And finally, we see a lot happening also in the process flow automation. So various processes being automated through generative AI, especially in the security and in the supply chain space. So lots going on as to how you can put these pieces together. And in many senses, the sky is the limit from that perspective. So now that we've got a little bit of a sense of what you can do, what the challenges are that function calling is going to help address, I'd actually like to jump in a little bit more and dig into the details itself of what function calling is and why it's useful from that perspective. So function calling itself provides a structured framework for providing consistent JSON responses, as well as the ability to call external tools and APIs. And when I say a consistent JSON response, I'm essentially talking about the model giving a consistent output of something that can be with regards to entity extraction. It can be with regards to data mapping, like similarity scoring, but with regards to some specific function, it's providing a consistently replicable output. And then on the other hand, as you take this a step further into kind of the second phase of this, it allows you to turn into a multi-turn kind of interaction where you can also call tools and APIs to create some kind of a user experience. And we'll jump into a little bit more of the details of that, of how that actually looks. But first, I want to give you a little bit of an overview, thinking about the life of a Gemini function call. So as a developer, you would generally start this process by defining two things. You want to start your kind of flow with some sort of a user input, as well as a set of function declarations. So the user input will obviously then be given by the user, but you've defined a set of function declarations in the beginning that essentially outline what functions you want to be available to Gemini for it to be able to select. And then the output that you get from Gemini when you actually make the model call at that point in time is known as a function call. And that function call is essentially some form of a structured JSON output. That was the first bullet point. If we think back to the slide earlier, the first bullet point, that structured JSON output. And some journeys actually end here, where they just take the structured JSON output and then use that in some kind of a downstream application. For example, the use case that we see quite a lot in this case is entity extraction. So pulling out different entities and using them for something downstream. Now, if you actually want to take that and make an API call with it, you'll take that function that has been outputted essentially from Gemini in this case, and then actually pass it to make an API call. And that will be passed back to the model as if, on the client side, and that will be passed back as a function response. And that function response is essentially a structured way of providing the API call information back to the model so that it can then provide a summarized response or make another function call if it needs more information in order to ultimately respond to the original query from the user. Now, this was a single turn example, and I'd like to actually take this and make it a little bit more concrete and take it to a multi-turn example. And what we've done here is actually around the movies, I believe. I think I wanted to go see the Barbie movie in Mountain View. So in this case, you can actually see the original query from the user that came in is around which theater in Mountain View shows the Barbie movie. In parallel, I've passed in, alongside the query as the developer, I've defined a bunch of functions that I want to pass in with that query so that the model could potentially select one that I can then use to make an API call down the line. So in this case, I've passed in functions around finding the theaters, booking tickets with the associated parameters. And passing that query as well as the function declaration into the model, we get the response from Gemini that says the name or the function call that you should make here is find theaters for Barbie in Mountain View. And we take that then, that JSON output, make an API call on the client side, which I'll actually show what that process looks like outside of the model here in just a little bit. And then we make that function call. We get back a function response and we pass that function response back before we actually generate the response text for the user. And so in this case, we saw that it's possible in 2 theaters, so AMC in Mountain View and Regal Edwards Theater. And we respond back to the user and say, okay, Barbie is showing in 2 theaters in Mountain View, AMC and Regal Edwards. And then we are actually getting the next query in from the user. And again, we're passing those function declarations in with the query. And we say, the user says, okay, can you book 2 tickets for me tonight? And again, the function call to book tickets here is exactly what is outputted, and this process would start again until kind of the multiple turns are completed. So,
Julia, I have questions. This is a great overview, and I'm going to go back one slide and talk a little bit through this life. Oops, sorry. There we go. Yep, no worries. So this is such an important flow. I want to kind of talk through this like as a developer and think about like what's the difference here between what I'm doing today and how this works. I think that'll help too when we start showing code examples. So you mentioned LLMs or generative models are frozen in time and they're unable to reach out. So normally, if I prompted like where can I find the Barbie movie, the generative model LLM is just going to come back with words, right? Like there's no that's just the default behavior of Gemini. Is that accurate?
yep.
Cool. And so in this case, we're basically giving it tools or functions, right? And so we can give one, we can give two, like the example you showed with the looking up theaters, getting tickets. So that part that's coming back from Gemini that's a native part of Gemini. I think that's a really important part here. So this you can probably explain it better than I do, but I think this is sort of a fine-tuned native part of Gemini that gives you back structured data instead of just a response. Is that accurate, or how would you say that?
I wouldn't call it fine-tuned, but I would call it the model knows that in this case, it's supposed to come back with a specific response
Gotcha.
because of some of the things that it's seen in the past.
Gotcha. So we can, as a developer, I can kind of think of this as, instead of predicting a text summary response, I'm predicting which tool to use and what parameters to call. But
Exactly.
the model's not doing that for me. It's just giving me that structure. So
Exactly.
like many of our viewers, last year we spent a lot of time fighting with prompts and prompt engineering, prompt tuning, to try to get out, like, please give me this part of the question and put it in this format. And I've worked on prompts for tens of hours just to do that. Whereas this is a part of the API that says, I'm just going to give you back a function name and parameters, right? And then the function call part, which I think we have a slide in a diagram in a couple of slides that shows, like, that function call, I can make that in my application code however I want. So I can use Python, requests, hit a REST API. I could use Java. I could use my favorite SOAP XML client, like whatever it is. I don't have to like teach Gemini that part, right? I'm doing that. Got it.
No,
And then finally, it sounds like I call an API, get a result, and then at that point, Gemini will decide, like, I have enough information. I'm going to give you an answer, or I'm going to use another tool to make a call. So is that a pretty accurate description of this flow?
that's a very accurate description of that flow, though we will
Awesome.
actually be foreshadowing here a little bit, enabling also some additional configurations for developers to decide if they always want, the model to respond with something like a fixed completion, or like always respond with a function call, always respond with a natural language response, et cetera, et cetera. So we'll
Gotcha.
continue to iterate and allow developers to kind of use those different features.
Yeah, it's super cool. And again, this will help. I think when folks start looking at the code of like, oh yeah, that's the flow and order of operations. And then the last thing I'll say is this slide is showing singleton. So this would be like the text modality in Gemini Pro or relatives. And then the multi-turn is like the chat modality. So this works in either case, and we'll show
Exactly.
some of that later on. Cool. Okay.
Exactly.
Yeah. Thanks for digging into that. It's such a crucial part of this. So we'll feel free to take it back. Thanks.
Awesome. Thanks, Chris. I think that was a great kind of deep dive here. So before I hand it fully over to you to really dig into the fun stuff and the interesting demos, I did want to just jump into kind of a little bit of an example here, of an example flow, exactly what you were talking about too. While we'll jump in the next section into seeing function calling in action and seeing how the LLM kind of extracts the parameters from a user's query, what I think is really, really important for us to highlight here is that we actually don't make the API call here. You do that on your application, on the application side. So the process that we as in Gemini handles is the function call and taking back the function response to produce a response for the user to produce that model output. All the three boxes that you see below, the kind of API parameters, the external API call, and then the API response, those three components are actually handed off to the developer to handle and then pass that function response back in from a model output perspective. So I think that's really, really important to highlight for folks because it gives you a lot of flexibility in what you're using and how you're using this. And so, as I've mentioned earlier, we actually have customers that stop after the function call, after that first kind of box, and just use that for something downstream that isn't an API call. But then those customers that do implement this as an API call will go through the following three steps and actually generate that function response and pass that back in order to generate an ultimate output for the user. So with that, I would love to hand it over to you, Chris, to take us into some more of the use cases that we see and some of the awesome demos that you've built.
Absolutely. Yeah, let's do it. Thanks, Julia. That's a fantastic overview from Gemini over the last few months all the way to like function calling, uh, which went GA last month, in fact. So
It
it's been a
did.
fun ride. And so one note about this slide here, because that another important point is it confuses and or scares people when they hear like function calling doesn't call the function for you. Why is it called that? There's a specific reason why, and it has to do with a structured model output, right? Again, if you've worked with generative AI anytime in the last year, you'll know that like struggling with that structured output is quite frustrating. And so, just like Julia said, think about places where you want to give a generative model a tool, which is one or three or five functions. It'll predict which one should be used based on the prompt and extract parameters and give you that. And because we're all developers here, like we can take that and go crazy with it, right? We can call REST APIs, we can use Python clients. So it's a really beautiful design. So don't let that scare you away. But in fact, I think it's a pretty empowering. Like I've been using all of the techniques that you all have probably been using as well, like injecting things into prompt templates and using LangChain to pass things from uh, uh, one source to another. And this is just a really clean native way of doing that. So I immediately, as soon as I first started using this, I'm like, yes, structured. I needed more structured output in my non-deterministic generative life, right? So this is super exciting. So let's get into use cases and live demos. And we have a whole bunch of them to solidify the workflow that Julia showed you. And I'm not going to deep dive on one demo, but rather show a bunch of different ones. We're going to start super simple and work our way up to some really cool examples that you can play with as well. So uh, this is the last slide I want to show before I switch over to live demoing. Remember, if you have questions, please ask in the chat. After this, we have some pre-submitted questions that we'll walk through, and we'll also take some questions from the chat. So please, as you're seeing things and thinking about this for your use case, ask away, and we'll most likely get to it in the QA section. So in these demos, I want to first take the workflow that Julia showed, the single turn, multi-turn, and do a deep dive on that with code and show you like how that works in the real world. So we'll start with a single turn, single function, super simple, and then we'll add multiple functions, we'll add multi-conversation turns, and then we'll get into some really cool use cases like how to use this to talk to BigQuery in natural language. So let's walk through those demos now. I'm going to flip to my other screen here. All right, let me get everything in order. So let's start really, really simple. Let me bump the font size up here. And so in this case, if I go into Vertex AI in the console and I go to the language tab, you can see there's a text prompt, chat prompt. So I'm going to select text prompt and just using Gemini 1.0 Pro 001 out of the box, I'm going to just ask it something and say, what's the exchange rate from US currency to Swedish currency? Let me hit my region here, submit. And so this is going to come back and say, as of today, insert date. The exchange rate is approximately this. However, exchange rates fluctuate constantly. It's important to check with the current source. So this is acting as like a core LLM or a core generative model, and you're just getting back like sort of a short loop of this was your question. I'm going to come back. uh, these may not be accurate, right? So it didn't actually reach out to anything to answer this, which is by design, right? This is why in Google Cloud, we treat things very securely, data governance, right? We don't want this calling out unless you want it to. So, if I ask other types of questions like, I like to ask things that have links in them, right? Sometimes people think if I pass a link to a generative model, like, will it just know what that is? Maybe it indexed it, maybe not. And so there's a neat little video here from the baseball organization here in the US that talks about how Google Cloud is used in baseball games to track really cool metrics like pitch speed and all like sort of 3D visuals of where the ball is going into the strike zone, things like that. So it's a 1 minute, 1 or 2 minute video. If I pass this along and say which Google Cloud products are mentioned in this video, Gemini comes back and Palm would do the same, and it says, "I don't have access to the internet. I don't know," which is a very valid response, right? So even if you put the link, there's nothing magic that's going to trigger it to say like, "Oh, I know what that is." Um, it's just sort of coming back with that frozen data, frozen training data. Sometimes it might say as of April 2023. It may come up with different reasons, but at least it's hinting us to like, I don't know what's in that link. You either have to give me all the info, or we have to figure out a different way to do this. So function calling is the different way of doing this. And so I'll jump over to this demo app here, and let me zoom in a little bit. So this is exactly showing a Gemini response on the left and a Gemini with function calling response on the right. Everything else is the same. And in fact, when we dig into the code, you're going to see all we're doing on the right-hand side is adding one keyword argument to Gemini saying, use these tools that contain these function declarations. So same prompt, what's the exchange rate from US to Swedish currency? And on the left, we're going to get a response from Gemini. On the right, response from Gemini with function calling. So let's compare them. And so left side gets similar to what we saw before. As of my latest update, the exchange rate is this. And it's not really grounding that to any particular date. It's just kind of pulling from what it was trained on. So I probably wouldn't want to trust the answer on the left if I were actually converting currency right now. On the right side, and we'll look at the code in a second, all we've done is give it a tool that'll call an API to check the currency exchange rate on a given date, and then return that back to Gemini, and now Gemini answers and says it's 10.35. And so you can double check that in Google search or your favorite currency website just to see, but that should be current, like as of today. This is what it is. So now that you've kind of seen like the problem and at least the results, like what that looks like, let's dig into the code and see how you can build apps like this that reach out to whatever services. This could be current information like currency exchange rates. This could be like business information like your customer database, your support tickets. Obviously Gemini and things are not trained on that, and so I think it's kind of neat that at runtime we can just make those requests. You don't have to index all of your customer management database or all of your document repo. So we'll talk through all of those, but I just wanted to show you like what's the difference, what am I getting, and hopefully that's clear here. So let's go to code, right? So let me bump up the size here. And before I jump into this, there's going to be a bunch of links at the end with resources, with things like code labs that you can follow along interactively, things like notebooks. So stay tuned. You don't have to grab all these links just yet. We'll put them in the description, and they're in a later slide as well. So in on GitHub, we have my team works with a repo we have called Generative AI, and there's a lot of cool stuff in here. One of the cool things in here is function calling examples. And so I want to walk through a modified version that I made of this function calling notebook so that we can start to see like, this sounds awesome, but what's the actual code look like, right? So I'll skip through this front matter. Feel free to read it on your own. In this very first example, we're just going to be using the Python SDK or the Python client library for Vertex AI. So we've installed that here in our Colab notebook environment, and I'll do the usual, authentication project, and then we'll get to some awesome function calling. So let me get this up and running. Cool. And then I'll define my project, initialize Vertex as usual, get my libraries. Again, this is just going to be using the Python client library in Vertex and the request library to call out to APIs. So we're ready to go. So let's load up Gemini 1.0 Pro, and we've instantiated that. So let's look at the code for the example that I just showed you, the currency exchange rates. And we're going to define a function, wrap it in a tool, call Gemini, and then we'll actually make an API call with requests to get the currency exchange rate. So think of this like 3 steps. First step, declare a function. Step 2, declare a tool. Step 3, call the model with that tool. That's it. No third-party libraries or extra things to do, right? So this function declaration is, think of it like I'm defining it in Python as a structured schema, and this maps to a subset of the OpenAPI schema. So nothing crazy here. All these types and descriptions are coming from what you might look at an OpenAPI schema, but you don't have to define the whole schema, which if you're like me, I don't spend a lot of time writing OpenAPI specs unless you're actually writing an API with API docs and routes and things like that. So this is super simple, in my opinion. You be the judge. You try it out yourself. So we're going to declare one function here in Gemini. So this function declaration is a primitive from the Gemini API. And I won't read through every line, but just to talk about the gist of what we're doing, we're going to name this function get exchange rate. We're going to give it a description, and then we're going to say what parameters does this accept, what are their types, and what is their description. And then finally, which parameters are required. So one thing I'll note about this, and I'll talk more in the best practices after we wrap up demos, is this is not just documentation for humans. Like, it's not just good practices of documenting my code and my doc strings. Gemini will use all of the information you see here to look at the function name, the description of what it does, and that will help it pick the right tool, if any, to answer a given prompt. The second thing is these parameter descriptions. These types and these descriptions are very specific. So I put here the date must always be in ISO format, and the currency symbol itself, like USD or SEK, must be in ISO 4217 format. And thankfully, like, Gemini knows what that means, right? Because it has a bigger context. And it's going to use all that information at runtime to possibly pick this function and extract those parameters. So all of that is design time work of, like, here's the function, here's when you should call it and how you should call it. And notice that in there, there's no API calls or anything yet. This is just the function spec itself. Second step is we're going to wrap that in a tool. So again, in Gemini, there's a native functionality of a tool that can have one or more function declarations. So we'll get to that in a second, where we start to have multiple things that it can pull from. So we've defined that, and then step 3, and the final step that brings us into the runtime part, is let's send a prompt to Gemini as we normally would, but we're going to add a tool that refers to the exchange rate tool that encapsulates our exchange rate function. So when I make this call, Gemini is not going, hopefully, not going to give us a summary right away, but it's actually going to give us a function call response. And this is exactly the diagram that Julia showed of, like, I I send a prompt to Gemini, and now I get out structured data. And so this is the structured part we were talking about. So whenever you're using function calling, you're intentionally going to get this kind of function call response. So this function call response has the name of the function to call and the arguments to call that function with, as extracted from the prompt. So this is all done at runtime. So again, let's look back at my prompt. I said Australian dollars. I didn't give the ISO code for that. I gave Swedish currency. Again, intentionally didn't give the ISO code. So you could try playing with different forms of this and seeing how well it does for entity extraction. But basically, it came back and said, so the date wasn't specified. You should use latest, which is correct. The currency we're converting from is Australian dollars. The ISO code for that is AUD. And we want to go to Swedish krona, which is SEK. So that all looks good. So now at this point, we're technically done with that part of function calling. And so now I want to actually make an API call. So again, your end user wouldn't be like making an API call. This would be happening in your application code, and I'll show you how to package all that up on the application side. But basically, this is what we have to work with now. And again, if you've worked with generative models at all, getting to this point was usually a exercise in sanity and, like, prompt engineering. So it's really nice. Like, this is we've brought it to a Python dictionary. It has keys and values of what parameters to use. So this is the kind of output that I love when in application code, because you don't have to parse it, you don't have to use regexes. We can just use this now however we want. So like Julia said, you could be done here, write this to a database, or I want to make an API call and I want to use requests. So in the next cell, all we're doing here is think of it like a templatized requests API call. And we are talking to this wonderful app called the Frankfurter app that gives you exchange rates. And we are going to pass it latest because we want the currency exchange rate as of today, as of now. And we're also going to pass in the body the parameters, the to and the from. We want to go from Australian dollars to Swedish krona. So we make that call and we get back from the external API. So we're no longer working with Gemini. We're just talking to an external system in Python. So we're kind of out of band. Gemini's waiting for our response. So we get back a response from the API, today's date, here's the exchange rate. And so now in this conversation turn, which we have not yet completed, we're going to pass that information back to Gemini that came from the API. So all this big list is really doing is kind of replaying the conversation. Like this was the prompt. Gemini, you asked for a function call to get exchange rate. I made a function call and I'm going to pass you back the response. So this line right here is, in my opinion, the most important line in this part of the code that says, here, Gemini, here's the response from the API. You do what you need now. And so now Gemini will do one of two things. It will either give a text summary response, which uses the prompt, that API call results or response to generate a summary, or it would ask for another function call. And we'll see that in a second. But I just wanted to show a very simple case. So the exchange rate came back with an answer. Exchange rate from Australian to Swedish krona as of this date is this. So pretty cool example. Like it's kind of neat to see where we gave structured definitions to Gemini, where a user asked an open-ended prompt, and how it kind of converged back from prompt API response to like generated response that's grounded in whatever API call we just did. So very cool. Now let's get a little more complex. And that was like a really simple function signature with one argument. What if we have 7 or 8 arguments? So in this example, we want to get the latitude, longitude for a given location. And there's a bunch of properties like street, city, county. So these are all components that make up an address. Like we know that as humans. But if we want to like pull out, a very messy list of addresses and things, we want to separate those components out so that we have them in a more structured way. So in this example, we have one function declaration. So we're kind of starting from scratch. Ignore the previous example. So we declare a function to get latitude, longitude. We define these properties that will make up an array coming back for a given address. And so now I can do the same thing and prompt, just like before. I'm going to send a prompt and I'm going to give it our location tool. And Gemini comes back and says, oh, yeah, you should call get location. That's the one function I have. And here are your parameters. So it pulled out the city, pulled out the country, pulled out the postal code state. And so now we can actually use those as individual components, which again is it's very common to us before generative AI. Like we did structured things, but now generative AI, we just get like a word soup. We try to parse it. So this is a really helpful way to get that structured output and use it however we want. Like I think in terms of meeting developers where they are, I think that we've done a really good job of that. I've heard lots of feedback from developers that are like, yes, structured output in generative models is great to have. So now we can unroll those arguments and make a call out to something like OpenStreetMaps, which has a geocoding service. And we can pass all of those parameters in the body, and we get back the latitude, longitude. Again, this would be easy to do if we had a very deterministic, set of inputs. But remember, we're dealing with like parsing random prompts from users, right? And again, that could be from a user, that could be from your workflow. Maybe you have a pipeline that does this a million times, right? So it's a really cool way to combine the unstructured creativity of an LLM or generative model and the structure we actually need to get things done when we're coding, right? So again, if you're using massive amounts of data, there's a maps, you can use the maps geocoding API. A lot of these samples are just made to be easy, so you can just run through them with no API keys. So feel free to check out this notebook and try the same thing. The last piece I'll show as we're like deep diving into the code version of the flow diagram that Julia showed is let's do a multi-turn conversation, so a chat modality with chained function calls. And this, the first time that I saw this happen in Gemini, it kind of blew my mind. And so when you run this, it may blow your mind as well, but at least you'll know why and why Gemini is behaving this way. So let's watch for different behavior than what we saw in the first examples. So again, I won't go through line by line. You kind of get the concept now. We're going to declare three functions, one to check inventory. These are all sort of made up. So we're going to pretend that we're asking and ordering products from the Google Store, which sells Pixel phones, Pixel watches, things like that. So we have a mock function here to check inventory stock. We have a function to get a store location and a function to place an order. You can imagine each one of these would tie into your inventory system, your store directory, and your ordering system, right? Actual API calls, either getting information or like doing things, right? So I like to think of this as generative models doing things or in action, right? Not just generating words. So we've defined three functions. We wrap them all in a tool. We pass it to Gemini. And now, let me make sure I've actually run these as I'm talking. Um, so now we are going to start a chat session and we're going to go through, I think, a couple of conversation turns. So let's see what happens here. And then we'll get to some really, really cool examples once we get solidify these mechanics. So first prompt, do you have the Pixel 8 Pro in stock in Mountain View, California? Now for reading that as a human, it's like, oh, I should check the store in the stock. How should a generative model reason through that? And so the first thing it's going to do is from its available function say, I need to get a store location first. That way I can check stock. So let's, so here's, it gave a function call response, get store location, and it extracted the user's city, Mountain View, California. And so now there is no API from the Google Store to do this, or at least one that I have access to or that you would. So we're just going to do sort of mock API responses. And this is simulating a JSON payload from such a system. So bear with me. What I really want to show here is the multi-turn and the chain function call. So let's say that we called an API and it came back and said, oh yeah, there's a store at this address and its ID is this, right? And so we'll respond with that to Gemini and see what the model does there. So now, this is sort of the mind-blowing part, at least was for me when I first saw it a couple months ago. We returned that API response to Gemini, and then it said, I want another function call response. Why? Because we only checked the store location. It now understands through its own reasoning layers that it needs to check stock. And so this is super cool behavior. And we'll talk about, like right now I'm doing this in a notebook hard coded, but we'll talk about ways that you might actually orchestrate that in the real world, right? So we returned a response and it came back with another function call response. And it said, I would like, and remember, this is a chat modality. So this is a stateful conversation. So it says, now I want to check the inventory stock for this product name at this store location. So it's kind of cool. It grabbed that parameter from our API response. So this is like a sort of a living process of like, let me research and find the answer for you programmatically to get you the answer you need and help you achieve your goal to the end user. So again, we'll do a fake mock API call and pretend that this was the payload coming back. And it says, yep, this is the SKU number. We have 28 of them in stock in that store. And so we'll return that to Gemini, and Gemini will then give the natural language response of, yes, we have 28 Pixel 8 Pros in stock at the Mountain View CA store. Very, very cool. So that was a single conversation turn in the chat modality with two function calls and two function responses. And again, depending on how your problem is framed, you may see this kind of behavior. And now you'll know why Gemini is asking for more information, just like a person would. Um, the last thing I'll say in the second conversation turn, great, I'd like to order a Pixel 8 Pro and have it shipped here to Sunnyvale. Um, and so here we get another function call response, place order, we get the address of the end user, we get the product name. We'll do yet another, fake API call to our ordering system. We come back and like say it's paid, it'll come in 2 days, here's your order number. And now we return that to Gemini. So we're returning our second conversation turn API response. And that's it. And it says, cool, I've placed an order. It'll be shipped here. You can expect delivery. So it's really nice that you don't have to like hard code those responses in your prompt template. There's none of that going on. You're seeing all the code here for function calling. So again, if I were doing this last year, I would have hundreds of more lines of code of prompt engineering and injecting templates and passing things back and forth. So hopefully you now have a really good understanding and you kind of made the concept your own of the diagram that Julia showed earlier of input, function call, return the response, and summary response. It's a lot to take in, but I hope the diagram concepts and the code like sort of solidify that. And run it yourself, and I promise then and play with it, break it, and I think you'll kind of quickly snap onto the pattern here. So that's a lot of mechanics. Let's take a step back and look at something completely different. If we go to the opposite side of the spectrum and say, okay, I can use this kind of tool to talk to a service. Very common service. A lot of the viewers probably use BigQuery in Google Cloud. This plays really well with things like Vertex AI and generative AI. So I thought to myself, if if we can use function calling to generate arguments to systems, BigQuery is a system. Can I generate some commands that I would use to send a BigQuery that would basically help me explore a data set in natural language, right? So I'll show some of the commands, but let me first show just how this works. So this is a Python app in Streamlit that's deployed on Cloud Run, and the application code is function calling in Gemini, and all the source code for this is actually available in our repo. So you can spin this up and play with it yourself. So I'm going to ask first, what kind of information is in this database? And we're going to see I'm printing out the what I call the sub iterations or the steps that are happening behind the scenes. And so if we look at those steps, we'll see, okay, Gemini first wanted to list data sets, and I'll show you the code in a second. It also wanted to list tables, which seems like sensible things to do if you're trying to understand what kind of data lives in a BigQuery data set. And then we returned those to Gemini and it gave its response. So you can kind of see how I've taken the pattern that I just showed in the notebook and wrapped that all up in a nice app. One thing to note, not everything has to be a chat app. It happens to demo very well because you can see transparently like what's going on. And I know chatbots are all the rage with generative AI, but I have a secret for you is that a lot of this stuff can actually power workflows and applications and pipelines that have no UI, they're headless, or they're just a really pleasant user experience, right? So a user maybe selects the product they want and then selects related products, and that can all be powered by function calling. Or somebody search for flights and wants to have a really personalized experience for the things they like to do. Maybe they have three crazy young children like I do, and they need some advice on how to handle that. Or maybe they really like hiking in the mountains. And so instead of just like doing all the research, I just want something that will allow that to happen. So I just wanted to make that comment really quick about the chat modality. Now, back to talking to BigQuery. So let's ask some harder questions and say, what percentage of orders are returned? While this is running, there's a whole write-up on this, and we'll give you the links to all of that in the description for this video. But basically, this is using a public BigQuery dataset that's called the Look e-commerce, and it's all synthetic data that looks like what an e-commerce company might have. So you have inventory and orders and users and things like that. So this is pretty cool. And I'll have to admit, the first time that I ran this through, I was very impressed. And the reason is there's a bunch of function calls happening on the back end. So I'll zoom in a little bit more. List data sets is happening first. List tables, get table, which gives us like the schema of a given table. And then my favorite one is a SQL query. And so I actually wanted to push Gemini to the limits and say, what happens if I have one parameter that's actually completely open into SQL query? It turns out it's not perfect, but it turns out Gemini can handle all of those pieces, and it's a really nice way to centralize kind of the brain for all of this. So I don't have to call 20 different tools to make this happen. So I asked what percentage of orders are returned, and it said 9.95% of orders are returned, and it gave information about the query that was used to calculate that. So most of us can write SQL or at least Google on how to do it, but do we want to? And so in cases like this, it's kind of neat because I don't have to like do a search, go to Stack Overflow, copy and paste some SQL, throw it in BigQuery. I can actually just have Gemini help me do that loop much quicker. And I could hand this to 100 business users that are not interested in learning SQL, even more not interested than I am not, and you could just talk to their database in natural language. So super cool use case. And take a look at this demo again. This is comes out of the uh, generative AI repo on GitHub. And I thought it was a neat use case. I want to point out one part of that. I won't walk through the full code example, but a few fun facts about this are that this application, including Streamlit, function calling, function declarations, API calls, all of that, the Python BQ client is about 250 lines of code, which I think is pretty awesome. And so I'll walk through here again. Now that you know the pattern, I'll kind of go through the big concepts. Number one, we define a bunch of functions. So we have list data sets, list tables, get table, and the SQL query. And so I'll pause at the SQL query one just to remind you that this has one parameter that we're going to pass to the BQ client in Python, and it's a query. And this entire parameter should be the SQL query that helps give quantitative answers to the user's question. And we give some more instructions in there about please use the fully qualified data set. And so those are our four functions. We wrap it in a tool here. We instantiate Gemini uh, with that tool. And the last thing I'll show you, because this is a little bit different than the other examples, is uh, when we actually go to the application code where we're driving these function calls, we're not hard coding it like we were in the notebook. So like I'm not sitting behind the keyboard saying, oh, they requested that function call, I'm going to call that for the user. And we want this all to be autonomous, right? We want this to act like an agent, and we want this to complete the task as much as possible on its own. So there's two lines I'll point out here before we move on to Q&A or the summary. One is this while loop. So this while loop is saying, hey, application, while Gemini is making function calls, because remember, it can make one or two or more function calls, please continue this function call response loop, right? And then the second one is these if statements. So this is like a really simplistic way, but a very understandable way of implementing. Now that I've gotten a function call response, how do I actually call that function? So this is the world's simplest non-production way of doing that. But the reason I show this is we have ways coming soon of doing these kinds of control loops in a very production way. And so function calling is one piece of it, and there are others that we'll talk about soon. So while the function calling is happening, depending on which function we have, we then just make that call in BQ with the BQ client. So there's no Gemini code here. This is just API calls. We return that to Gemini and ultimately return a summary response. So play with the SQL Talk app, break it, see the limitations of while loops and if statements for this kind of thing. But it's a really interesting experiment on like what can you do beyond the hello world examples in currency exchange. And we'll have a video of this coming out in a couple of weeks that we'll put up as well. That goes in a lot more detail. Okay, so let me go back into the slides and Things in order here. Great. So let me wrap up and we'll get into Q&A very, very soon. Um, one quick note on timing. I think Julia may or may not have to jump in a few minutes, and that's okay. We'll drive you through the Q&A here. So benefits of function calling. Uh, don't take my word for it. I've been working a lot with everything I say is on behalf of you all, of developers, right? So I come with no opinions here. I just want to help you all get your job done. And so I've noticed 3 or 4 different themes coming up of why developers think this is awesome, especially with all the churning and fighting we had to do last year with LLMs of like, how do we behave when we have this random word generator in our stack? So 4 things, you can read this yourself, and we have more blog posts on this, but developers love having full control. So there's nothing that's making API calls behind the scenes. There's nothing magic happening. You have full control. Like we give you a function name, we give you parameters, and you do 100% what you want. Number 2, there's less boilerplate. So this SQL Talk app, earlier implementations I had of this were about 1 or 2,000 lines of code, lots of templating, lots of prompts. Number 3, fast prototyping. This might be my favorite one, or the ones that developers love the most. You don't have to wait for us or a third-party library or framework to ship a connector to any kind of service. You just do it. You just take your existing call, and now you're mapping it to an LLM of like when and how to call this, but your call is the same. And last, there's no opinionated stack. You can actually use function call completely like I did in the SQL Talk app, with no LangChain, no additional frameworks, or you can use it with LangChain. So we're not trying to change the way you work. We're just trying to help you bring a little bit more determinism in your life as you're trying to deliver, creative generative outputs to your end users and customers. Um, I'm gonna leave these. I'll briefly talk through these. Best practices: use a sensible number of functions. Don't try to do 100 functions. It probably won't work well. You want to break your problem up. Uh, the accuracy of selecting functions and doing parameter extraction really, really depends on your specificity. So be specific that you're teaching the model how and why to use this tool. Think if you were teaching somebody how to use tools for a given problem. Uh, Last few things: specify types as much as possible. And we talk about Open API schema part, the subset that we're compatible with. Uh, Aim for determinism. Use low temperatures, please, because remember, your temperature here is not just generated text. It's actually how Gemini behaves when reasoning to pick a given function and a given parameter. So this is probably not a place where you want to crank it up to 11, or you're going to see very non-deterministic behavior, especially for testing, but just for consistency. And then finally, few shot examples are still relevant. You could add a whole uh, novel worth of prompt, but if you give a few shot example, Gemini is going to have a much better understanding of like, oh, okay, like I should call this and then this and then this to get that kind of dependency information out. So let's wrap it up as we come up on time and get to Q&A. If you are as excited as I was when I first discovered this, we have a number of resources you can use. We have an interactive code lab, a sample notebook, very similar to the one I showed, and wonderful documentation. All of these links will be going in the description, so don't feel free like you have to jot them down quickly here. Uh, Other resources, you can join and engage with our community if you're not already. A great place to ask questions about function calling or Gemini or LangChain or any of this stuff is the AI community on the Google Cloud community. You can share your feedback, please. We'd love to hear feedback and ideas for future sessions. And I suspect Julia and I will come back to talk about deeper parts of how to operationalize these workflows. And finally, there's some really good upcoming events. It's a packed schedule. So tomorrow, there's Data Cloud Innovation webinar, and you can see other events coming up in the next week with more information on the Google Cloud community site. So with that, and Julia, if you have to bounce, I totally understood. But let's run through some Q&A. We are going to start with support for third-party. So we had pre-submitted questions. Please keep adding your questions to the chat. We're going to start with 3 topics of really good questions that were asked. So support for third-party tools, OSS frameworks, and languages was the theme. And some of the questions were, how does function calling in Gemini compare to LangChain? How can we integrate LangChain with Gemini? So that is an excellent question. It's probably the first question that I get back always in this case. Uh, so number one, function calling is not a replacement or an alternative for LangChain. LangChain does an incredible amount of things. We love open source frameworks. About half of our examples in our repo use LangChain. So we're not looking to replace LangChain. What this does is function calling specifically is about structured data outputs and function call responses that tell you which tool to use and when to use it. Uh, LangChain is a superset of that, right? It does lots of other things. You can actually use them together, and anywhere in your LangChain code where you need more explicit function calling, you could do this explicitly and say, I'm going to make a function call here, then return it to the LangChain stack. That's fine. You could get really fancy and start to integrate LangChain with some of Gemini's behavior. But long story short, you can use it without LangChain. You can use it with LangChain. Totally fine. Stay tuned for more code examples and more example usage of this. This is a really big point for us because we know developers and customers want to run LangChain on Vertex. So we are very excited about that. Second question, is function calling only available for Python or will additional languages be supported? We already support additional languages. So the really good news, if you go to the function calling documentation in Google Cloud under Gemini, we have lots of Python examples. We also have Java examples, Node.js examples. So any client library that works with Vertex AI will and should have the Gemini API built in. So you can look at the Vertex client libs page, search for those, and use that in your language of your choice. No, you need to use Python. So there's REST API, Python, Java, Node, and a couple of others. So it's already supported. Please let us know. We'd love to hear all the different languages you're using, like how it's going, feedback on how to make it better. Love to hear about it. Number three, how can we deploy an application on that uses Gemini function calling and LangChain on Google Cloud? This is an excellent question. Stay tuned. Probably a future webinar, probably a future release. There's something that's not quite out yet in public preview, but it will be soon, that will really help the story of deploying these kinds of LangChain on Vertex agents with that. So today we talked about function calling. Stay tuned for part two. We'll put out, you'll know about it. We'll put out blog posts. We'll probably have another session, but stay tuned. In the meanwhile, you can see a lot of the code samples we have for wrapping all this up with function calling and deploying it as is, like the BigQuery app that I showed. Second topic in pre-submitted, and then we'll jump over to a bunch of the wonderful questions that were asked. This one deals with handling runtime logic with function calling. So a couple of questions came in. They're kind of related, but they are unique. One is, if I make a request to Gemini function calling and it can't fulfill the request, how can I enable the model to answer general purpose questions or perform a RAG operation, like some kind of fallback? This is a very good point. So Gemini Gemini and function calling are fairly new, right? They went in public preview in December. Function calling went GA in February. So we're still learning. We'd love to hear this kind of feedback. As of right now, you would have to kind of build in that control logic either directly in your application code or with something like LangChain that says, like, hey, if you get back a response that there are no available tools or you can't do that, you then need to make a Gemini call without a tool. So that's the simplest way to do it right now. We are looking into ways of handling this better. And really, this kind of logic belongs in the orchestration layer, the deployment layer. So again, stay tuned. The second question here is really good. How do I manage LLM function calls while still allowing the user to interact? And there's an example here, but I'll kind of paraphrase it. If the user asks about flights, we make an API call, we get back flights. We don't want to answer the user. We want to actually present them flights, have them pick, and then send that as an API response. Can you do that? Absolutely. One of the things I said about developer control is that this you have full control in the loop. So like if you're in the middle of the loop and Gemini has made a function call response, you can do with that whatever you want. You can make an API call, return the results. Like As long as you're out of band of Gemini, you can return that to the user, have them select the subset of flights they're interested in, and then pass that back to Gemini. So one of the beautiful things about this design is that it's decomposable, it's decoupled, right? You don't have to do these things in a particular order. So you can absolutely do that. And a fun thing would be to like modify one of the sample notebooks to do exactly that. And the third and last pre-submitted question topic, and then we'll jump to the live questions. I know we're a little bit over time, are we? I don't know, but I'll keep answering questions. And so we'll go maybe 5 or so more minutes. So I appreciate you all for sticking around, and this will be recorded. If you have to jump, please feel free. So the third topic, the consistency in output and model quality. This is a big deal. We're still dealing with generative models, right? And they're still non-deterministic. Question regarding the accuracy of model responses. Can the model guarantee consistent responses in JSON format without extra characters or unexpected behavior? To this, I can give a resounding yes, because it was the very first thing I was interested in, because I immediately took all of my prompts to like generate JSON with no triple backticks, with no language specifiers. Like I just want valid JSON, but the models wouldn't listen to me. And so this, when you send a tool argument to Gemini, it will, and it comes back with a function call response. It will be structured. So there are no prompts in there. I wasn't hiding any secret prompts from you that say, please generate valid JSON or structured data. That's all happening natively as part of this functionality. And the second question here, do you experience inaccuracies in returned function parameter values? Sometimes LLMs give a dummy value because they're kind of forced, their reasoning is forcing them to put a value, and it might give an inaccurate parameter. How can we guard against this type of behavior? Very good point. In my own work, and with developers, I have seen more, how should I say, I've seen more behavior in the quality as like, oh, it picked the wrong function or it filled the parameter. And usually following the best practices I gave earlier, you can deal with that. You can deal with that by being specific in your prompts. I have not seen Gemini hallucinate field values. You can also tell it in the description, like uh, ask the user if they don't provide this information or use this value as a default. That's worked well for me. But this is all such an important part of testing and quality testing. Have a known set of inputs and outputs, not just the input summary and the output summary, but the reasoning. So imagine you were teaching somebody, like a coworker or a friend, how to do something. You want to teach them the tools to use, but you also want to teach them the process. And that's exactly what you're doing with Gemini. So, with that, I am going to jump over to some questions, and we have so many wonderful questions. Thank you all for asking. If we don't get to it, I highly recommend that you go to the Google Cloud Community Forums and ask there. I'll go around there. Our support folks are there. Our DevRel folks are there. So please go there. We don't want to leave you hanging, but we do have to cut short here. So we'll take about a few more minutes here. Maybe go through 3 or 5 questions. We'll see how it goes. So I'm just reading through them. Give me 1 second to catch up on all these wonderful questions. Let's see. I see one here. I noticed you use a temperature of 1 for the structured output to return for the location example. I imagine that is to have the response returned without variation. Oh, sorry, this, and then they had a follow-up. It's a temperature of 0. That's absolutely right. In the best practices, and thank you for this question. Um, in almost all of our tutorials and code examples of things, you'll see us setting temperatures to 0 because we need hundreds of thousands or millions of you all to all get to the same answer and reproducible. And that's very important to us. And so don't feel like that's a absolutely necessary part of doing this. That being said, when it comes to function calling, I like determinism. I think that even in a production setting, you should think about having this in the lower temperature. Uh, the answer to this question is testing. So do testing, have 10 or 100 different sample inputs and outputs with reasoning steps, and see what happens, see how it changes. You'll probably find a sweet spot of the behavior. So thank you for that question. Uh, let's see. Another really good one. I really appreciate this question, Tomek. So having the first currency exchange example, if we add a tool to read the current date, would it chain to function calls? This is actually a very common question, and there are easy ways to break our sample apps because they're not production; they're made for teaching. This is one of them. So if you ask the currency exchange app, what was the exchange rate from USD to Sweden as of 2 weeks ago? It has no idea what you're talking about unless we've grounded it with the date in the application code or given it an expensive function. So what I would do is to take the burden off of the user is in my application code, uh, either you could either do this in the function declaration, or you could do this in a chat conversation turn. I prefer the first, but both work. And you could say today's date is, sys.date, like pull the date in your application, pass it to the LLM, ground that, and just to make sure nothing crazy happens. So you could ground it, application code. You could make a function call if it's really important. Uh, uh, with parameters, maybe high frequency trading or something, right? Like, so yes, you could do that, and it would chain to function calls if the prompt involved time and dates, right? We would expect it to first retrieve the current date and time, and then retrieve currency information. Let's look at a couple more questions. Thank you for these wonderful questions. Here's one from Rishi. Hello, what if the question asked only has a few parameters and more are needed to call the function? Will it ask to provide other parameters? You should try it. I think playing around with these kinds of prompts and parameters is a really good way to see the different kinds of behaviors. So there's kind of the happy path behavior of function call response, generated response. There are other behaviors. And so the model might come back right away and ask, like in a chat modality, and ask, okay, I got your address, but which product did you want again? Like you may have left it out, or it may not have known. So my best advice here is to try it out and see what are the primary flows that's going on and what are the other edge cases that's going on, and how can we design our user experience to account for that, right? um, so yes, it will usually ask for other parameters, but try it out and play around. um, let's see, maybe one more question. This is a good one. I like this question from Riff. Thank you for that. Do we have examples how to get model to read a Git repo? um, Maybe, but more importantly, I really like this approach. There was one example I didn't get to because of time. That's okay. I'll push it out in other through a blog post, let's say. But some people have asked, could you use this to do a RAG operation? Right? RAG is retrieval augmented generation. It retrieves documents, sends it to the LLM, and summarizes. Absolutely. Like function calling is a primitive. You could point it to a vector database like Vertex AI Search, uh, your favorite open source vector database, like Milvus or ChromaDB, would work absolutely fine, right? Because you're just defining the function signature, calling that. Now you don't have to call a RAG, right? You could call the GitHub API. And so I was talking with a customer who wants to build out a system where their support team can take tickets with long stack traces and error logs related to networks, and then search their Git repos for which team is likely to know what the heck's going on with this problem, that I can route it to them. And so in their case, they're actually making API calls to the GitLab, GitHub APIs, there's tons of parameters in there that you can call. You can call repos, you can call code. And with the increasing context window size as we go on in time, you can send pretty large amounts of code through. A fun exercise might be to grab the sample notebook I have, and instead of calling a geolocation API, call the GitHub API. Put in your API key and do some simple things like say, what were the last 10 commits that I made, and or what are the last 10 contributors to my projects? Things like that would be really fun to work with. So the possibilities are endless. If you can call an API or run a function, you can use it with function calling in Gemini and bring those worlds together. So Thank you for the amazing questions. Um, I'm going to stop it there. And again, if I didn't get to your question, I'm sorry. Thank you for those who pre-submitted questions. Amazing. Thank you for the live questions. If we left you hanging, I'll meet you in the Google Cloud community with your question, and we will find you there. So thank you everyone for your time. I really appreciate it. Stay tuned for so much. We're just getting started with function calling. So stay tuned for more samples, more awesome use cases, and we love to hear from you. So try these resources that we're showing here. We'll have them in the description. We'll send out the recording. And thank you all so much for your time and participation today. And happy function calling. And I hope to see you out in the community. So thanks everyone for your time. And thank you, Julia, for joining earlier. We really appreciate it. See you next time. Thank you.